Hi guys, these are the practice problems for 4.1b, okay? So they give us a function and they ask us to find the second derivative, so we can do that. We did it in 4.1a. So f prime of x is 18x minus 18, and f double prime of x is 18. Okay, all right, so that's part A. Okay, so look. In part B, they ask for local max and local min, but they ask us to use the second derivative test. And I don't know if Mr. Hunt taught the second derivative test, but I don't use it because if I do local max and local min, I already know how to do that, right? So why to relearn how to do something we already know how to do? So if I just keep my first derivatives for local max, local min, increase, decrease, I can keep my second derivatives for concave up, concave down, and inflection points. So we did the second derivative. That was easy. So for local max and local min, we got to find our critical values. We set the first derivative, which was what? 18x minus 18 equal to 0. So x is equal to 1. And remember, for these functions, this is what? 9x squared minus 18x. So it's a positive x squared. So I'm just going to know the shape of the graph. If you want to go plug in numbers to the derivative, you can. I know this looks like that. So I have no local max, and I have a local min, and x is equal to 1. And so how do I find the y part of that point? Y is going to be f of 1, and you plug it into f of x, which is your original function. So the original function is 9x squared minus 18x minus 216. So when I plug in 1, I get 1, whoop, turn it on, clear. 1 store for x, enter, 9x squared minus 18x minus 216. And then I get negative 225, and then that's my y value, negative 225. My x goes in, my y comes out. There's my x, there's my y. All right, so for me, I'm not going to use the second derivative test. If you want to, you're more than welcome to. But if we look at the second derivative here, they're telling you it's positive. That's telling you it's concave up. So it's going to make it a local min. So we already know this. So let's just stick with what we know. And I'm going to, again, stick with the shapes of my graphs, okay? If I have a positive x squared, I know it looks like this. It's concave up, never concave down. There's a local min. A negative x squared looks like this, okay? There's a local max, no local min. And then the cubic functions. I have a positive x cubed, and my two critical values, I'm always going up, down, up. So I have a local max, local min. And if I have a negative x cubed, it always goes down, up. It goes down, up, down. Okay, so that's my local min, and that's my local max. So if I remember what these four functions look like, I'm in pretty good shape. Okay. All right, so here we go. Question number 2 is f of x is equal to that, and they want, I believe, just the local max and local min. They didn't ask for the second derivative, so they probably did say use the second derivative test, but I'm not going to, because why? What does this function look like? It's a negative x squared. It's going to look like this. So it's going to have a local max and no local min. So let's take the first derivative and find that point, negative 14x plus 14 equal to 0. So I get x is equal to 1. So there's my 1, and I know it goes up and then down because it's the shape. And so I have a local max at 1 something and no local min. So I plug my 1 into the original to find my y. So I just do my 1, store for x, and enter, and I plug in negative 7x squared plus 14x plus 245. Enter. 252. So my local maximum occurs when x is 1 and it's 252. Okay, so it's just like reinventing the wheel. I'm not going to go through the second derivative test to find local max and local mean because I already know how to do it. Okay. All right, question number 3. Sometimes they ask for the second derivative, sometimes they don't. But if they do, that's not really a big deal because I know how to do that. First, we find f prime of x, which is 6 times 3 is 18 x squared plus 8 and 8 is 16 x plus 360. And then what is my second derivative? 36x plus 162. So we put that in and they say, great job. And then they go, find the local max and local min. So I'm going to take my first derivative to find my critical values and set it equal to 0. Now, can I take an 18 out of everything? So 162 divided by 18 is 9. 360 divided by 18 is 20. So yes, if I take out an 18, I get x squared plus 9x plus 20. And so when I multiply two numbers to get 20, 5 times 4, and they add together to get positive 9, that's what I have. And when I set it equal to 0, that doesn't have an x, so I get x is negative 5 and x is negative 4. So we have to really be careful because you have to know that if at 0, negative 1, negative 2, negative 3, negative 4, negative 5, those, okay? And now I don't have to pick a fraction because what's my original function? It's positive x cubed. So what do I know it looks like? It goes up, down, and up. Okay, so I have a local max at negative 5 something and a local min at negative 4 something. So I plug negative 5 into the original and I plug negative 4 into the original. So f of negative 5, do negative 5, store for x and enter. And then I plug in my original function, which was 6x to the third plus 81 x squared plus 360x minus 90. And then I get negative 615. So that's my y. And then I find f of negative 4 for my local min. So I just go to my calculator and I do negative 4, store for x and enter. And I plug it into my original function, plus 81 plus 360, x minus 90. I get negative 618. Get my dog, y'all. Okay. All right, so that's it. Local max, local min. It's a cubic function. I know from the onset it's going to go up, down, up. All I had to do is find my two critical numbers, and I don't have a lot of work to do. Okay, so you can do the work, you can do the second derivative test, or you can do it like me. Whatever is easier for you. Okay. Here's another one. Okay, they don't ask for the second derivative this time. Oh, 3 is 4. Okay. And they just say local max and local min, so I don't have to do anything except find the derivative. 18x squared plus 36x minus 270 is equal to 0. Hopefully an 18 will factor out of everything. So I say 36 divided by 18 which is 2, minus 270 divided by 18, which is 15. So when I factor it, the 18 is not going to give me anything because there's no x. X times x, and 5 times 3 is 15, but to add to get positive 2, it's got to be positive 5 and minus 3. So I set x plus 5 equal to 0, x minus 3 equal to 0. So x is negative 5 and x is 3. So I make my first derivative sign chart with negative 5 and 3. And since my original function is a positive x cubed, I know that it goes up, down, up. So I have a local max at negative 5 something and a local min at 3 something. Whoops. So I have to find f of negative 5, because you always plug x into the original to solve for your y. All right, so let's do negative 5, store for x and enter. And plug in my original function, 6x to the third, got to come down, plus 18x squared minus 270x. Enter, and I get 1050. So that point is negative 5, 1050. And f of negative 3, no, f of positive 3, sorry, is my local min. So I just do my 3, store for x, and enter. And I go up and I highlight my antiderivative that's already there, and I push enter twice. And I get negative 486. So that's the y part of my point. And here is my answer. There's my x and there's my y. So the local max occurs when x is negative 5, and this is the maximum value. My local min occurs at x is 3, and here's my minimum value. Okay. All right. And then question number 5, it's another polynomial. It's cubic. It doesn't ask for the second derivative. So I'm just going to go find my critical values. It doesn't matter that they asked me to use the second derivative test. Coffee break. Okay. So f prime of x is negative 18x squared plus 126x minus 216, and I set that equal to 0. I hope a negative 18 will come out of everything. So that would give me x squared, 126 divided by negative 18 is negative 7. And then negative 216 divided by negative 18 is plus 12. Okay, so okay. Ooh, that looks a little better. All right, so negative 18, and I got to factor this, but I know that I'm not going to get a value because there's no x there. So x times x, and 12 is 6 times 2, but that can't add to get negative 7. And 4 and 3. 4 times 3 is 12, and negative 4 and negative 3 adds to get negative 7. So I set my equal to 0. I get x is 4 and x is 3. So when I put those on my first derivative chart, and there's 3, put them in order, and there's 4, and this is a negative x cubed is my original function, so I already know how it looks. It's going to go down, up, and then down. So there's my local min, and here's my local max. So my local max is at 4 something, my local min is at 3 something, and to find the y part of my points, I plug 4 into the original, and then I plug 3 into the original. Okay. All right, so let's do that. Let's do 4, store for x, and enter. I'm going to type in my original, negative 6x to the third, come down, plus 63x squared, okay, minus 216x minus 18. When I push enter, I get negative 258. So there's your x and there's your y. So x is 4 and y is negative 258. And that's your max. So my minimum should be less than that. Let's put in 3 and store for x and enter. And then all I have to do is I've already got my function in there. And I get negative 261. So yeah, negative 261. And that's my x and that's my y. And I have my local max and my local min. Okay? So I'm just using, okay, so these next 3 are, I don't know what that looks like. I don't know what x to the 4th looks like. Like I do know x squared and x cubed, so I'm going to have to go through the process, but I'm not going to use the second derivative test. I'm just going to use the first derivative test. So f prime of x is 4x cubed minus 16x and set it equal to 0. Okay, so I have to factor that. But first, let's take out the greatest common factor. And that leaves me x squared minus 4. So now when I set 4x equal to 0, I can't just scratch it out because there's an x there, okay? I'm solving a cubic equation. I should get 3 answers, right? So x squared minus 4 factors. It's a difference of squares. Okay, so when I set 4x equal to 0, I solve it and I get x is 0. X is negative 2. And x is 2. Okay, so I'm going to put my critical values. These are my critical values. On my number line, in order, negative 2, 0, and 2. And we're going to pick test numbers in each interval. Let's just pick negative 3, negative 1, 1, and 3. And remember, test numbers go into the derivative. So f prime of x is what? 4x cubed minus 16x. And since I have so many numbers to plug into my derivative, I think I'm going to go and use my table. Clear it. I'm going to put my derivative in, 4x to the third minus 16x. Oops. I hate it when I do that. So 4x to the third and then minus 16x. And I push enter, enter, enter. Now remember, your computer calculator might be set on auto. And if that were the case, you would just have to scroll up and down to find your numbers. I just like to set mine on ask so that I can delete whatever is there and I can just ask. So I can say, well, what do I get when I plug in negative 3? I get negative 60. So f prime of negative 3 is a negative number. That's all I care about, right? And f prime of negative 1, let's do negative 1 and enter, is positive 12. And all we care about is that it's positive. Okay. And then let's put my next test number in, 1. I don't know why I did store. And I get negative 12. All I care about is that it's negative. And let's put in 3. So f prime of 3 is positive 60, and all I care about is that it's positive. Okay, so now let's draw my arrows. Down, my derivative is negative, I'm going down. Derivative is positive, I'm going up. Negative, I'm going down. Positive, I'm going up. Remember, a local max looks like this at a critical value. So this is my local max. And then a local min looks like this at the bottom. So I've got two of them, a local min and local min. Okay, so I have a local max at 0 something. So I have to find f of 0. I go to my original function, which is x to the 4th minus 8x squared minus 8. Okay, and I'm going to plug in 3 different numbers. So let's just go back to my table function and put in x to the 4th minus 8x squared minus 8. Enter, 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 enter. I'm on ask, so I can delete whatever's there. And then I can say 0, enter, and I get negative 8. So my local maximum point is 0, negative 8. Okay, that one's right there. And then I've got 2 local mins. So I have a min at negative 2 something and a min at 2 something. Okay, so I said f of 0 was negative 8. Oh, that's not f, that's f prime. So f of 0 was negative 8 and negative 2 and enter. I get negative 24 and put 2 and enter, and I also get negative 24. So I plug my x's into the original to find my y's, and I just use my table function. So I put 0, negative 2, and 2. So when I plug in 0, I got a negative 8 out. So that made me 0, negative 8. Plugged in negative 2, I got a negative 24. When I plugged in positive 2, I got a negative 24. So these are my answers. Okay, local max and local min. And what is that? This is problem 6. X to the 4th. Okay, so now problem 7. And it looks a little different too. And it is asking me for the second derivative. So we've done this before. We did a second derivative before of a quantity to a power. But first, let's go find the first derivative. The first derivative, we have to use the chain rule. And then multiply down times the inside to the first times the derivative of the inside. Okay. All right, so now how are we going to find the second derivative? Okay, so I can, let me move this a little bit. I can rewrite the first derivative as 4x times 2, which is 8x times 2x squared plus 7. And you could do the product rule, but I mean, since it's not to a power, you can just distribute it and say, well, f prime is what? 8 times 2 is 16x cubed plus 8 times 7. Y'all, I'm so bad. 8 times 7, 56 plus 56x. So this is the first derivative, this is the first derivative, and this is the first derivative. Okay, I just turned it into a polynomial. So what's the second derivative? It's 48x squared plus 56. Okay, and now they want local max and local min. So what are we going to do? We're going to set our first derivative equal to 0, but we have the first derivative where we factored it, which is really easier. Set my first derivative equal to 0, and I set 2 equal to 0, I don't get anything. I set 2x squared plus 7 equal to 0. I get 2x squared is -7. X squared is -7/2. So when I try to square root it, I get no solution. So I get, you can't take the square root. If I tried to take the square root, second function, x squared of -7 divided by 2, I would get domain error because so there's no solution on that one. But I can set for x equal to 0, and I get x is 0. So my only critical value is x is 0. And remember, if I have a local max or a local min, it has to occur at 0. Okay, so I'm only going to have either a max or a min. So let's pick test numbers and plug them into my derivative, f prime of -1 and f prime of 1. And so here's my derivative. It doesn't matter which one you use. This one, this one, this one. So if my derivative, let's go to our table, is 16x to the third plus 56x. Enter, 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 enter. I want to get rid of the stuff that's there, so I have to push delete. And so I have my derivative in my function. Let me check. 16x cubed plus 56x. Yeah. And I want to do -1. F prime of -1 is -72, so it's minus. And F prime of 1 is +72, so it's positive. So it goes down, and then it goes up. So what do I have when x is equal to 0? It meets at the bottom, so it's a local min. There's no local max. And how do I find my y value? I plug it into my original function. Remember, my original function is 2x squared plus 7 squared, and f of 0 is, let's say I do 0, store for x and enter, and I type in my original function, 2x squared plus 7 squared, boom, I get 49. So my point is 0, 49. And that is my answer. Okay, one last problem to work. Okay, so you see patterns. They asked me for my second derivative, and then from there on out, I ignored it. If they want local max and local min, I'm going to find my first derivative. Okay, there it is. When it's factored, it's easier to set it each factor equal to 0 and find your critical values, which was just x is equal to 0. And when I plug in my test numbers to my first derivative, I could have used this version of it. I could have used this version of it. I could have used this version of it. I just chose to use that version of it. It really doesn't matter. Okay, so you'll get the same answer anyway. All right, so last problem. So it's a lot like this problem. Let's look at it. Okay, so I've got 2x squared plus 7 squared, and I got one critical value, and I had one local max or one local min. Okay, this is going to be a little different. It's all because of this minus sign right here. Remember when we went to solve 2x squared plus 7, we got an x squared is a negative number and there's no solution, but now that's not going to happen. So let's go look at this. Although they look very similar, they are different. Okay, so last problem, I think. Yes. Okay, so it's asking for the second derivative. So we're going to find the first derivative using the chain rule. So f prime of x is 2 times 2x squared minus 8 to the first times 4x. Okay, And when it comes to finding the local maximum critical values, I'm probably going to use that derivative because it's already factored. Okay. But to find the second derivative, I'm going to rewrite this as I'm going to multiply the 2 times the 4x and get 8x times 2x squared minus 8. That's f prime. And then f prime is, I'm going to distribute 16x cubed minus 64x. So now I have a polynomial. So when I find the second derivative, we'll move that down a little bit. It's 6 times 3 is 18, so it's 48x squared minus 64. And I won't need the second derivative again. That's just step 1, since I am not using the second derivative test. All right, so let's go through how I found the second derivative. First derivative, multiply down, times the inside, times the derivative of the inside. Okay, so you can multiply the outside numbers, which gives me 8x. And since this is not to a power, I could use the product rule here. You could do the product rule if you wanted to. I just chose to distribute and get 16x cubed minus 64x because it's easier for me to just take the derivative of a polynomial. So 16 times 3 is 48x squared minus 64. That's the second derivative. Okay, so then they say local max and local min. Well, I know if I have local max and local min, I have to find my critical value. So I set my first derivative equal to 0. And like I said, I like to use my first step of my first derivative because it's all factored. And I just set each factor equal to 0. So when I set 2 equal to 0, there's no x there. But when I set 2x squared minus 8 equal to 0, I can take out the 2 and get x squared minus 4. And sure enough, I'm going to get x is negative 2 and x is 2. And when I set 4x equal to 0, I get x is 0. So I've got 3 critical values. X is negative 2, 0, and 2. Okay, so because of that minus right here, I could solve the inside, right? X squared is a positive number. I could factor it. Before I couldn't. Okay, all right. Also, let me just show you this. You might have wanted to say 2x squared minus 8 is 0. 2x squared is equal to 8. X squared is equal to 4, but I have a lot of people say x is 2. But remember the square root property. X is plus or minus the square root of 4, which is plus or minus 2. So that's why I usually factor it, because people forget that it's plus or minus. But whatever you decide. So I'm going to make a first derivative chart with my negative 2, my 0, and my 2. My dog is crying. And since I've got so much to plug in, I'm going to plug my first derivative. Here it is. I'm plugging into my first derivative. And I can use that, or I can use 16x cubed minus 64x. This time we'll just use this one. 2 times 2x squared minus 8 times 4x. So as long as you're using the derivative, you can't mess up, whether you use the 16x cubed minus 64 or this one, doesn't matter. I'm going to delete what's there. Oh, crap. All right, so when I do that, okay, it's intuitive to push clear, but I'm going to have to push delete. So let's plug in my test numbers. So f prime of negative 3, enter, and I get negative. I just get a negative. Let's just don't even worry about it. Negative 1, enter. F prime of negative 1 is positive. F prime of 1 is negative, I bet. And F prime of 2. Remember, I plug my test numbers for local max and local min into my first derivative. Whoops. I couldn't pick 2. 0, that's a critical value. I have to pick 3. So F prime of 3 should be positive. So this gets positive. So now I have my positives and my negatives, and I know if my derivative is negative, my function's going down. Here, my function's going up, going down, and going up. So now I have a local max at 0 something, and I have 2 local mins at -2 something and 2 something. Okay, so where do I plug these values in to find the y part of a point? Always go to the original function. And my original function, let's go to my table. My original function is 2x squared minus a squared. I'm going to delete whatever's there. Delete, delete, delete. And then 0, enter, and I get 64. Plug it into my original. -2, enter, and I get 0. And 2, enter, and I also get 0. So I'm plugging these numbers into my original. So to recap, test numbers plug into the derivative. Critical values plug into the original to find the y part of your point. Okay, there's your x, there's your y. And that's it for section 4.1b. We have one section left, and I'm going to get that posted later today. I know, like, Mr. Hunt has the lecture notes, so this is just me working problems. Okay, as always, let me know if you have questions. And